move on. This is so fascinating, though. We could spend literally hours on this tool right here.
Yeah, I think it's a good idea, Dr. Faith. Keep moving. I think these folks know where the app is, so they can do that at 3 a.m. when they So let's keep going. Thanks.
Yep. Oh, gosh. Predominant occupations. There's just no limit to what you can do with this. Okay, we better move on. So back on the outline, folks, let's go to number 6 again, and let's go ahead and click on that time zones, what we call a Geo Inquiry. So time zones, Geo Inquiry. So when you pull that up, time zones, you're going to get what's called a metadata page. The data about the map that you're about to open and the activity that you're about to open. So we have a body of content and more resources we'll talk about during the workshop. But if you say, hey, you know, I kind of get the idea of looking at patterns, relationships, and trends with these geotechnologies from local to global scale. I kind of get that. Now, how do I actually teach with it? Well, that's where the Geo Inquiries come in, is that each one of these is a one-page lesson. You could run it for 20 minutes in the classroom. You could run it for an entire classroom. We know teachers that run it for several days at a variety of different levels, okay? Primary up to a high school. I even know some university instructors that kind of take these lessons and then extend them for their university courses, okay? So that's what these Geo Inquiries are. In this particular case, it's part of our collection on grade 4 interdisciplinary Geo Inquiries. And so the geo part, map-based, the inquiry part, asking questions, uncovering relationships like we've been doing here in the workshop. So if you pull up that link, you're going to see a page that looks like this one that I'm looking at right here. This particular one is focused on time zones. But again, as we talked about earlier, think outside the box. This is just one example. Maybe you don't care about time zones. Maybe you don't teach about time zones. But it's one example of what you could do with these mapping tools. There are about 140 Geo Inquiries, and they're not the end-all be-all. They don't cover every single topic that you find teachers are teaching, but they're hopefully planting ideas and giving you confidence that, okay, here's a set of questions that I can teach with, and if I don't like those questions, I can make up my own, but I've got the map right at my fingertips. So go ahead and skim through the metadata. It just basically tells you what I just said, that you can use it on any device. It's a lesson and a map is basically it. So if I go ahead to the upper right-hand box there, which says open, go ahead and open the Geo Inquiry. It's about time zones, as you can see. Here's a couple of links to standards, shows you some learning outcomes. We're going to look at the locations of places and regions and their environmental characteristics. A little bit of math context there. We're going to look at some distances, intervals, so on and so forth, okay? So here's, if you scroll down a little bit, there's a couple things that I wanted you to notice. First of all, there are some questions in there. Does each time zone have a name? Look at a couple of selected time zones. We're gonna look at San Francisco, Denver. Again, customize it for your own area. Look at El Paso. Why is West Texas in the Mountain Time Zone? It totally makes sense why it is, right? Instead of the Central Time Zone. And then what time is it in other places? So we're gonna do a little bit of that. And then what happens when you fly from one time zone to another? And then how are time zones subtracted or added, okay? So those are some of the questions that we're going to be asking here. That's basically it. So as you can see, if you printed this out front to back, it would be one page.
Yeah.
Now
Okay.
Yep.
Can I chip in a bit? I want to highlight to the folks here that we distributed a hard copy of this, I believe. So we printed this time zones Geo Inquiry for you.
Oh, you're the best.
In the resources folder, you'll find a folder either on Google Drive or in Dropbox. There's a folder called Geo Inquiries. You also find these PDFs that are there. But these are just examples of Dr. Kay said. Okay, good. That's okay. Back with you.
Well, fantastic. Thanks for doing that. So folks, each lesson, just so you get the idea, is, again, one page. It's got some questions in it. which you can use or not use depending on if you like them or not. But I think most importantly, it has a link. Each one of these has a link, as you can see this big stripe across the top third of page 1. It has a link to a live interactive web map in this platform called Arcgis Online. Okay, so go ahead and click on that link if you've got it in a digital form. If you don't, you can always type it in. The URL isn't that long, really. All right, now when you pull it up, it should look something like this.
Yeah, you can also copy and paste it.
Yes, you can copy and paste. Very good. Now I'm using the Chrome browser. This should work on Safari just fine. It should work on the Edge Microsoft browser. The older versions of browsers like Internet Explorer, old version, you kind of, it's a little bit hit and miss. So, you know, use the browser that actually works well for you. All right, so how are folks doing? You see that web map there?
Yeah, I think they're all there. So far, so good.
Ah, very good. So now you can see the pattern of the time zones. Yep. Now, one way I usually start this with students, I have them think about the following. You know, when Magellan and his crew sailed out from España, right, from Spain, and sailed around the world, right, around South America, over to the Pacific, down Southeast Asia, and then around Africa, and then back to Spain again. When they got back, even though it was obviously not the whole crew anymore, and Magellan had died, and it was basically a quarter of the original crew, as you probably remember back in 1522, their records were 1 day off of Spain. In other words, their chronology, their time that they thought it was 1 day behind. And it was so interesting to people that they sent a delegation over to the Pope in Italy saying, look, we sailed around the world and we're 1 day off. That was the first inkling, the first idea that people had that maybe we need, if we're going to be sailing around the world and it's a sphere, then we need an international dateline, right? So what's amazing to me is that, you know, here these people were just about, you know, famished, and they were eating, as you probably remember, you know, shoe leather and ropes and things like that, right, to stay alive. Even so, they were like, we need to keep accurate records of the number of days that have passed. And they were so accurate that what happened? They didn't advance, right? They didn't advance when they crossed the middle of the Pacific. So that's why they were 1 day behind Spain when they got back. Very interesting. So, okay, get the students thinking about that kind of an interesting historical fact. But then look at the time zones. Why do we need time zones? So how does it change in different places around the world? So does every place have roughly, right, and the sun goes by, the earth turns about 15 degrees an hour. So you've got this zone, right, where if we wanted to divide up the world, we could divide it in such a way that every 15 degrees of longitude, we've got a different time zone. And that's indeed what roughly we have in the USA and the Western Hemisphere here. So we've got this sort of area going right here, okay? But not every place in the world has that, as we'll see in a moment. So in this case, I like to zoom in on the mountain time zone since that's where we are. You can do that as well. Why do you have this big chunk of southern Idaho actually in the mountain time zone and northern Idaho is in the Pacific? Well, we have these interesting local adjustments. And some things I can't really answer. For example, you've got this county line between the mountain and the central time zone, right? Why they didn't run it up the state line like you have in Texas, New Mexico? It makes sense that it's on the state boundary, but notice some of the counties in western Kansas and western Nebraska and western South Dakota and North Dakota, they're on the mountain time zone. Why didn't it just run up the state line? It would have been a lot more convenient, but maybe there were historical reasons for it. Anyway, really interesting. So get the students thinking about, okay, if it's 9:52 in the mountain time zone, what time is it in Mexico City right now? Okay, it's in central, so get them to add and subtract the time zones. So lots of things you could do there. Also, if you scroll out, you've got this nice convenient west-east arrow, as you can see. Yep. So as you can see here, you can navigate on the map. You can use the plus sign and the minus sign in the upper left, or you can just pan across with your touchpad or the mouse to pan the map. Yeah, one more thing. Well, two more things. Let's go down to Australia. This is an interesting thing that touches on geography and mathematics. So if you click in the eastern part of Australia, and let's say your students are 11 years old, they have no idea where Australia is, right? So if you type in the upper left, or sorry, the upper right-hand box, if you type in Australia in the search box, it'll pop you right to it, okay? So kind of think about the level that your students have about where places are around the world. They might not be able to pan to Australia because you and I know where it is, but the students might not. So just go ahead and use that search box to find places. So here's another tip. If you type in Australia up there in the upper right, look, you can say add to map notes. See there in the resulting box? So now you've got a map note sitting on Australia. Very cool. All right, so you're using what's called ArcGIS Online here. You've got the full ArcGIS Online interface that we're going to come back to time and time again all day long. All right, so back on our investigation in Australia. So click on the eastern, and this is where, you know, when you and I say eastern, you're instilling a little bit of spatial thinking. Where is east and where is west? Where's north? Where's south? So you're getting the students to think spatially by these phrases that you're using. So, okay, eastern side of Australia, it's going to be on the right side. Yep. And you can see here, if you click in there, that it's time zone 10. So you add or subtract hours to Greenwich Mean Time to get to time zone 10. But now, if you click over in the western side of Australia, it's time zone 8. So kind of think about the USA. If we only had 3 time zones, let's say New York was 9 o'clock, then, and it's Eastern time, right? Then Central time would be 8 o'clock and Mountain time would be 7 o'clock. So that's kind of like what it looks like here in Australia, right? So if Sydney is at 9 a.m., Perth would be at 7 a.m. But what about the middle of Australia? You'd think it would be 8 a.m., but it isn't. That's what makes our planet so interesting. The middle of Australia, good day, mate. She'll be right. Good on you. It's at 9:30. So it's a half hour different from Sydney, right? Wow. Now, this is a pretty simple base map, right? It's just got a gray background. On the left side of the map, you see where it says base map? Go ahead and change the base map to something like topographic. So you see some city names in there. Topographic, okay, great. You could also change the base map to something like OpenStreetMap. If you change it to OpenStreetMap, you'll see some city names and some different looking. You've also got National Geographic. You've got a variety of base maps there. Very cool. All right, so.
Let us know if you're lost, right? So that you, yeah, the idea here.
You guys good? All right, so what I'm getting at is if it's 9 a.m. in Sydney, what time is it in Adelaide? Interesting. It's not 8. So do a little confirmation. Go ahead and do this. What time in Sydney in a tab, for example, in a web browser? So right now it's 3:56 in the morning tomorrow. What about one of those cities that you found in the central part of Australia, Adelaide? It's 3:26. It's a half hour different, as you can see in this web map. So it's not 9:87, it's actually 9:8:30 7. Isn't that interesting? So there have been a couple of times when the central part of Australia, Northern Territory and South Australia, had a vote, a referendum on their ballot. Hey, do we want to be on the hour or do we want to stay on this half hour? They voted to stay on the half hour. Interesting. That's what's great about the Earth. There's all kinds of interesting little anomalies. Get your students thinking about that. Okay, if it's 9 a.m. in Sydney, it's going to be 8:30 in Adelaide and also in Darwin here in the Northern Territory. And it's going to be 7 out there in Perth and other cities on the West Coast. Interesting. So if you scroll up to the north, you'll see that time zone 9 is due north of the Northern Territory, and they are on the hour. They're not on the half hour. Yeah, fascinating. So it's just Australia that does that. Now go ahead and pan over to China, or type in China in the search box. Some of you may know this. I'm going to add to map notes again. I'm going to click in here and look at the size of this time zone 8. It's the whole country. Isn't that interesting? So discuss with your students, perhaps, what are the advantages of having your whole country on one time zone? There's got to be advantages, right? How many of you have ever had a conference call with someone in a different time zone here in the USA, and you got to kind of scratch your head thinking, okay, we're going to have that one central, and that's going to be, 12 mountain time, right? So you've got to do this mathematics calculation in your mind. But if you're in China, hey, the whole country's on the same time zone. That's kind of convenient, isn't it?
Hi, Dr. K.
Yes, sir.
Just a little comment. I think what you're saying, I experienced that a lot myself. One thing I didn't mention in my introduction is that I'm from Zimbabwe, in Southern Africa. So I collaborate a lot with folks on the African continent and also some in Europe.
Mm-hmm.
A lot of the teleconferences that we have, sometimes, it's way 2 a.m. here in the US, and I'm up to talk to those guys. They just go to work. So I do identify with what you're saying there regarding differences in time zones.
Yeah, and it's fascinating when you pan over to Africa and you look at time zone 1, which is 1 hour later than Greenwich Mean Time. And then you go over to like Egypt, Sudan, East Africa, they're on time zone 3. But the south central part of Africa is actually on time zone 2, which is the same as Eastern Europe. Yep. So if you go from like Sudan over to Chad, you're skipping 2 time zones. Interesting. Yep. So back on China though, folks, for a moment, you can see the advantages of having a whole country on the same time zone. One of the interesting things, I think, would be get your students thinking about, if we were if everybody in the USA was on the same time zone like they are in China, then let's say the sun comes up at 6 o'clock in the morning in New York City or Boston or someplace on the East Coast, right? So give them pan over to the USA here. So if it comes up at 6 o'clock in Boston, and let's say the whole country's on the same time zone, well, the Earth is turning on its axis, right? The sun probably doesn't, if we were on the same time zone, the sun probably wouldn't come up in El Paso until like 8:30 in the morning. And it probably 9:30 over in San Francisco, right? If we were all on the same time zone, it would come up really late on the West Coast. So when you think about that, for China, if you're in Beijing and the sun's coming up at, let's say, 6 o'clock in the morning, if you get way over to some of these cities in the western part, which I admit is very low population, but what if you're over here in Urumqi or Aksu, way over in western China, the sun probably, again, doesn't come up till probably 8:30, 9 o'clock in the morning. Interesting. Yep. So there's a lot of, back on the lesson, there's a lot of mathematics in that lesson that you could draw out in a richer, deeper way. We just touched on a couple of things in the map, but coming back to the lesson, you can look at the different time zones and have the students calculate, okay, if it's 12 o'clock noon in Greenwich, what time is it going to be in New York City? So a little bit of math integration, nothing more complicated really than addition and subtraction, but they're also thinking about Earth-Sun relationships at the same time. And they're using maps, they're using the zoom, the pan, the measure tool, and some other things on the map, okay? Questions, comments?
Are we all happy, folks? Before we move on?
The maps, are they current? Are the maps current, like from this month, this year, or how current are they?
Yeah, so good question. So let's say you've got a map like this in ArcGIS Online. Now, time zones don't change that often, right? I mean, if Central Australia voted to be 1 hour different from Sydney or Perth, then we would have to change this map, but it's not going to happen all that often. But other maps, right, if you're looking at real-time wildfire perimeters or current population or something like that, then you're going to want to make sure that the map that you're using is actually up to date. And so, yeah, some of these maps, especially in these Geo Inquiry collections, are actually what we call curated, right? They're like a museum piece. They're updated, they're maintained, and so on. So that's a really critical part in this, is where do the maps come from and who created it and how up to date is it? Yep, good question. Because these are all dynamic web maps running in this ArcGIS Online cloud.
Okay, great question. Any other comment or question so far? All right, I think the folks are happy, Dr. K. Let's keep moving.
Right. Folks, since we're going to be using this same interface, we want you to get comfortable with, the basics. Zooming and panning, using the search box in the upper right to find places, El Paso, Australia, etc. And then on the left side, we touched on base map and how to change the base map, right, folks? You did that. But then also, we didn't touch on this really, so I thought I might bring it up for about 10 seconds here. And that is, to the left of the map, you've got a content and a legend, right? So the legend in this case is the different colors are the different time zones. Yep. The content is the layers that you have in the map. And you can turn that on or off. Okay? You can turn those layers on and off. So here you've got a map, you've got one base map, and then you've got 1, 2, 3, 4, 5, 6, 7 layers in it. I added map notes. I've got 7 layers and a base map in this map. Okay? So those are the key tools. Measure tool. We didn't actually do it as a group, but you could measure the distance across the mountain time zone, for example. If you grab that little measure tool and you measure in, let's say, miles across, you could click on the map and then click on the other side of it. It looks like it's about 700 miles wide or 1,100 kilometers-ish. Yep. All right. What about from here to England? Oh gosh, look at this. Why is this line curved? Why is my line curved? Why is my line from El Paso to the UK, if I wanted to teach about, where is Greenwich and Greenwich Mean Time, where does that start? Why is it curved? instead of straight. Interesting. Yeah, I see you gesturing. Yep, good. Hey, again, get out a globe. Put a string from El Paso to London and see how far north it goes, right? It's going to touch the tip of Greenland and go across Iceland, right? The whole idea of the Great Circle Route, that we're projecting a three-dimensional Earth onto a two-dimensional map here. And so if you measure a long distance with that measure tool, you're going to see a curved line. Absolutely. Very cool. So there's a lot of concepts that you can kind of get across in this. So basically, I wanted to get you familiar with the legend, the content, the measure tool, finding places in the upper right-hand box, zooming and panning, and that would be all. Everybody good?
How is it, folks? You know, there's a bit of exploration going on here. We have to push on. I think you guys are not familiar with all right. Hi, Dr. K.
Greetings.
Yes, I think you know, the folks here have been exploring a bit. How is the temperature in the room? Do you guys want to switch off the heating? It's hot? Okay. So let's request Alicia to find. Can you check if Dr. Stahamba? Yeah. And then we switch off.
Where's Rob?
The room that should be facing. Yes. So I think you know, the folks here, Dr. K.
Yes.
They've been exploring a bit, and I think they get the idea. Let's move on for the sake of our schedule and time. The next activity here is maybe for these folks to get out of their seats a bit and do a bit of measurement. All right, bullet number 7. Are you done with bullet number 6, Dr. K?
Yes, I just wanted to point out, folks, that the reason why we love using these geotechnologies in the classroom are exactly what you folks just did, where you're starting to investigate and you're doing things that aren't even in the lesson necessarily, but you're asking questions, you're investigating, you're playing with the tools. And so that's exactly why these things are so compelling and so useful. So anyway, good for you folks. I commend you.
Emphasizing the issue of food, guys. So I don't know what we can do, but we don't want them to chase us out of there. I don't know what they really would not allow us to eat in their land. So maybe so educators are interesting, right? I heard someone say you can hide it. Hide the food under a desk, then I guess with all kids, then they go time out, right? Once you find out that you're hiding the food. But you know, yeah, please just take extra care so that we don't mess up, you know, the computers in the lab. I think that's the biggest concern here. Let's see. How was the data collection? Okay. It was just a little exercise to familiarize you guys with the data collection exercise. Let's find out if Dr. K is back from his coffee break.
Yes, sir.
Okay, so it's over to you, Dr. K. So these folks, they were collecting data through your survey here. So we're on bullet number 7. You can take it away to discuss whatever they did or didn't do. Okay.
You folks are great. Isn't it great to get out in the field and do some data collection and some mapping? Yes. All right. Well, okay. I did the same thing you folks did. I went into the field and I used the same form that you are seeing right here. And I used it on my phone. So the idea is, and you'll do this afternoon, you can actually create a survey like I did here that you used for the vegetation on a variety of different topics. Again, invasive species, weather, water quality, pedestrian counts on intersections in your community, graffiti, whatever it is, you can actually do that. Now, how many of you have ever created a survey like in Google Forms or SurveyMonkey?
Yep.
Okay, several folks. It's going to be the same thing, the same kind of experience this afternoon that you've done in those other tools. In other words, you're going to be just dragging multiple choice or true false or fill in the blank or a number from a web form over to your survey. And the nice thing about using GIS is that the results of your survey actually goes into a map, into an interactive map in this same ArcGIS online platform, okay? So that's what we're going to analyze next, realizing that this afternoon you're going to create your own survey. But what Dr. M and others and I decided was, let's get you out there collecting so you kind of get the idea of what it's like using the final result, and then we'll take a look at the map. Then this afternoon you'll go out and create your own survey, okay? So let's go to the outline, and inside, you've been in number 7 of our agenda for today. Inside number 7, you opened up the survey itself, correct? You opened it in a web browser, and you also opened it up on your phone. Nice. Let's go ahead and take a look at the second link in number 7 there, the resulting map, okay? So it's another tinyurl.com, and it's the one that goes Y7, et cetera, the one that begins with Y7. So go ahead and pull up that map. So the survey, as you see here, looked like this. It's a very simple one. We basically said, okay, tree height, tree condition, species, and then a map and a photo. Okay, pretty simple. But we wanted to keep it pretty basic. The resulting map that you're pulling up right now, when you open it up, when you open up that tiny URL link, it's going to be defaulting to another part of the country. Because this is the last place that I actually was out in the field with some students collecting data on the University of Colorado campus. Go Buffs, okay? So you know, based on our time zones activity, how to get the map panned down to your part of the world. How do I do that? What's one way to do that? Yep, you can find address or place, or you could pan the map. You could do a variety of things. If I pan the map to the south, and if I zoom out a little bit, I'll show you that I wasn't just slacking off while you guys were working. I collected a point too. And my point is right here, if you just south of Boulder, down in West Denver. And so I'm going to pull up my point, and here's my photo. It's not very exciting, but it's basically the tree species that's outside my window right now. So while I go ahead and pull that up, you go ahead and pan. Here's my photo. So this is what it looks like up in Colorado right now. No snow on the ground, all dry, about 10 degrees colder than what you are right now. So that's the point I collected. Now I'm going to pan the map to the south a little bit, or look up a place name in the upper right. And if I go down to where you folks are hanging out today, wow, if I zoom in there, look at all those points. You folks are busy. Since this is an extremely local area that you folks collected data in, what base map might be a little bit better than the one that's defaulting right now? What would be a better base map? Yeah, I agree. Maybe imagery with labels. Go ahead and try that. Feel free to change it if you don't like it. But if it's a really localized, like it's just a school campus, like you guys are there, I'm just going to go ahead and change it to imagery with labels. Wow. And now go ahead and test. Go ahead and click on a couple of those points and pull up some photos. Now, as you'll notice, as you click on those points, that some of your colleagues were out in the field about 3 weeks ago collecting data on the same campus. So I'm going to try to find a point that was collected today and see what how the vegetation changed. That could be an activity, right? Have your students go out and collect different vegetation images at different times of the year and talk about seasons. Oh, look at that. Very nice. So I wanted to make sure that you folks could go to the map, zoom to your location, and go ahead and pull up some of the information that you just collected. Everybody good with that? So is everybody good with going to the map, pulling up some information about what you just collected?
Yes.
Okay, super. I'm going to go back to the map. I'm looking at a photo right now. One of the things I usually talk about with the students at this point is how close were you to your actual location on the ground? So now we could get into some of the details of how this satellite image was created, for example. It is not perfect either. But if you accept that the satellite image is within a few centimeters of its actual location, some of the points you may be a meter or two off of where you actually stood. In other cases, you might be 3 or 4 or 5 meters or 10 meters off. So I like to talk to the students about positional accuracy. If you're inside the building, you're going to be compromised on your spatial location. So it's using, the app is using GPS, the GPS constellation, number one. Number two, it's using the triangulation off of cell phone towers. And number three, it's using triangulation off of Wi-Fi hotspots if they're geolocated. So the combination of those three gets you your location on the planet. So if the students are inside the building, or if they just barely walked outside and now they're collecting a point, it might not triangulate all three of those right away because those signals can't penetrate solid objects. So there might be a nice little integration of a little bit of discussion on precision and accuracy and mathematics right here, and also geography, your position on the ground. So depending on, again, the time of day, if they've just gone outside, if they're in heavy, a canyon, or in downtown Albuquerque or downtown El Paso where there's a lot of tall buildings, their position might not be within a meter or two. It may be 5, 10 meters off. So it's a nice little teachable moment right there. But nevertheless, you can see that it was pretty easy to go ahead and pull up the app. If you have the app, if you don't have the app, all you have to have is the web browser pointing to the survey. Now, how did I make this map? You'll do this afternoon. All I did on the map was I said, I want to add my data that is actually the layer that is my survey. So once you add a layer to the map, it's mapped, right? So one of these layers I have on the left side of this map is just simply the survey that I designed and you collected into. See what I mean? So what you'll do this afternoon is you'll design a survey, and then you'll share it, and then you'll put it in a map. So those are basically the steps. You design the survey, you collect data into it, and then it feeds into this map that you create. And then you can share the map if you want to, or you don't have to if you don't want to. So yeah, very nice. Now, if you have that workflow in mind, then that's really all there is to it. So creating data with a survey called Survey 123 and mapping it. Questions, comments?
Any questions, folks? Or comments on this little exercise that you did?
Awesome.
Yeah, hopefully no. Okay. Well,
Awesome.
Awesome.
Cool. So let's dip into number 8 just a little bit. If we want to further...
Everyone looks okay with the comment, yeah?
Okay.
Okay, I just had a curious question. When I was out collecting data using the app, it prompted me for the information in meters. But when I'm sitting here at my desk entering the information, it prompts me in feet.
Yep, good point. I need to fix the map. Yeah, it's important to know what units you're collecting in. Yeah, it is actually in meters, but I have to adjust the map because I was using this for a different purpose. Yeah, so good call. Good thing that you noticed that. Yep, good to be consistent. So that's my fault. I didn't fix the map. But here's something that we can do on the map. All of these points have different attributes, right? The I part of GIS, the database behind the map, is what's driving the content of the map. So if we go to the map and you go to the content tab to the left of the map, you'll see some tools underneath the University Campus Vegetation Mapping Survey, correct? You'll see a table tool. If you go ahead and open that table, it's going to open, as the name implies, the table of data that you and others collected in. So that table tool looks like a little waffle, a little tiny table database. So if you open that, notice how it's got deciduous or evergreen, condition, species, et cetera, right? So those are the things that you can map. But that's the I part of GIS. It's the table behind the map, as we saw in another activity here earlier. Okay, so the table is there. And then another thing that I'd like you to pull up is this whole next tool called Change Style. Do you see it's the one next to the Open Table button to the left of the map? Go ahead and change style. All right. So what if we change the style and said, you know, I don't want to have these just mapped on location. What if I want to know about deciduous versus evergreen, for example? Or any of the other attributes in there. I'm going to go with deciduous or evergreen. So I've only got 2 choices in there. So if I go to deciduous versus evergreen, then I can go ahead and say, done. Now I've got 2 colors, and go ahead and pop up the legend there. It's just to the left of the map. So you've got 2 different colors, deciduous or evergreen. You also might have an other. Yep. So now I can see which trees were deciduous and which were evergreen. So that's just a matter of changing the attribute that you're mapping. Now, what if you didn't like the size of those symbols? Those are awfully small, aren't they? Especially on a satellite image base. What if I don't like the size of those symbols? Can I change those? It's once again under Change Style. So if you go to the Contents tab, remember how we were just saying, oh, I want it to be mapped on deciduous versus evergreen. So I did that. You did that. And see under number 2 where it says Select a Drawing Style, you've got where it says Options there on the left side of the map. So change style and go to Options. And then you're going to be able to go to Symbol and actually adjust the size of the symbol. Yep. So I'm going to go to Change Style, Options, and then I've got Symbols in there. And I can go ahead and say, you know what? I don't want an 8-point symbol. I want these to be 20-point symbols or whatever it is that I want. See, now I've got bigger symbols. Yep. And now I can see the pattern. The whole idea here is to see patterns, relationships, and trends. So let's say you were collecting this on, and let's say you've got like a cuesta or some sort of ridge by your school, and you had the students look at tree height and tree species on the north-facing versus the south-facing slopes. They should be different, right? The north-facing slopes have a different soil moisture content typically, and they tend to be more heavily vegetated than the south-facing slopes, correct? So you could do an analysis on tree species and tree height versus the north-facing versus south-facing slope. By the same token, you could do a map. You could make a map on. Let's say you went out and collected data on pH or dissolved oxygen in a local stream or a canal running by your school. You could map it so that you've got different colors or different size symbols for a different value of the water quality. You see what I'm getting at? You can change what you're mapping here.
They are really messing around with it good here.
Ah, good.
Yes, it's a lot of adventurous mapping that is happening here.
Yep. All right, folks, you ready to do a little bit more experimentation with the map that you have in front of you?
Yeah, I think they're good to go, Dr. K. They're experimenting a lot already. So, yeah, you move on with them.
So you know how to change the style, correct? You know how to change it, for example, to look at condition or deciduous versus evergreen.
Yes.
Okay, super. Let's do two more things with this Arcgis Online interface. First, if we go to content, remember, you're going to be looking at all the layers in here. And right now, you should really only have the base map and the survey itself in your content. Okay, so you've just got two map layers, basically. Well, let's go ahead, and we've already looked at the table of data. So we've looked at the first tool, and we've already looked at change style. It allows you to change the symbology of your map. Now, you math teachers might like this. We'll get into this more, hopefully, this afternoon. But underneath change style, you've got additional capabilities. You can make standard deviation maps. You can classify the data differently, like quantile versus equal interval versus manual breaks. So you can classify the data differently depending on how you want the map to look and how you want the data to be displayed. So there are lots of good math integrations here. The next thing, though, let's do a filter. Let's filter the data. Sometimes in working with mapping tools and geographic information systems, you actually have too much data. Let's say you're mapping all the earthquakes from 2018. Well, that's thousands and thousands of earthquakes. Maybe you just want to focus on the earthquakes above 7 in magnitude. Or let's say you're mapping cities in the USA and Mexico, let's say. And let's say you only want to focus on the cities over 1 million people. Okay, that's where the filtering comes in. You only want to show things that meet a certain criteria, okay? So if I go to the filter tool, which is really the fourth button in, the first one is showing you the metadata, the second one is the table, the third one is the change style, and the fourth one is the filter. Don't get too locked in, though, to where these buttons are, because this interface is rather dynamic. The important thing is to know why you're doing what you're doing. So in this case, we're going to filter down the data. And this is where, again, you've got some nice, computer coding, expression, mathematics integration here. Because in this case, you're going to build an expression. You're going to create an expression. I want to know where the condition is good. Or maybe I want to know condition is poor. Do I have any trees around your campus where the condition is poor? Maybe I need to pay attention to those trees. Maybe I need to give them some TLC. Maybe I need to give them some extra water. Or maybe we need to put some earth around them, or some sort of compost, or something like that. Okay, so I only want to look at condition is poor. Does that make sense under filter? So that's my statement. Condition is poor. And you shouldn't have to actually type in anything. You should be able to just use the drop downs to create your expression. Now I'm going to apply filter. And now, if I go to my table, remember, open that table. Now I only have 281 trees out of the 300 and some odd I had before. So around your campus, all of these ones that are showing up right now, let's go ahead and filter. Condition is poor. Let's do that. Condition is poor, apply filter. And now if I go to the table, yeah, now I only have 21 trees. Condition is poor. Around your campus, the only poor condition trees, according to what you folks collected, are this one out to the west across the parking lot, and then there's one right outside the front door that someone put it was poor condition 44 minutes ago. Does that make sense? So I only have 2 trees in your area that are poor condition as classified by you. Does that make sense? So what did I do there? I said condition is poor. So that was the filter tool. And again, think outside the box. I only want earthquakes above 7. I only want cities above 1 million, or I only want places where there is X kind of soil condition and Y kind of precipitation. You know, those are the kinds of things that you can do. And how do I remove that? Well, I simply go back to the filter tool, and then I say remove filter. So filter, remove filter. Now if I remove filter, I'm going to see all the trees again, right folks? Yep, let's practice that one more time. So filter, and this time change your expression. Let's say I want the species is, and there's a lot of unique species in there. So species is, I don't know, ash. Let's look at that. Do you have any junipers around there? I thought you'd have like a lot of junipers and pinions and stuff. So I'm going to say, okay, species is ash, apply filter, and now I only have this one. Sort of on the south side of the school building that you're in, or the education building that you're in. Does that make sense? So filtering can be a really powerful thing. Very good. Muy bien. Okay. Let's move on. Is everybody good with filtering, changing the style, and opening the table? No hay problema.
Okay.
All right. All right, folks, you guys are doing great. So the reason why I had you change the map a little bit is a couple reasons. A, you're building some geotechnology skills. You're going to keep coming back to these same tools. Zooming, panning, opening the table, filtering, changing the symbols. Those are the kind of, what, Dr. M, about 12 or so of these core tools that you keep coming back to, okay? Yep, so you're going to get more and more comfortable with those as we go on. The second reason why I wanted you to do that is because you're seeing that, wow, these maps are not just static, right? I can customize them in various ways. I can filter down the content. I can change how they look. I can look at the tabular data. Lots of different things you can do here. Yeah, excellent. Super. All right, folks. And this content can be anything. It could be earthquakes. It could be capital cities of the world, etc. So we're just using vegetation as an example of the things that you can do in the mapping platform. So let's go ahead now and do one more thing that's kind of a core thing in this number 8 exploration of the ArcGIS Online platform. Now, the reason why I call it anonymous exploration is because I'm logged into in the upper right here, it says actually Joseph, but in your case, you might not be logged in at all, correct? It might say sign in. How many of you have a sign in where it just says sign in there?
Yeah.
Okay, so you're not, some of you aren't even logged in, and that's good, right? For that time zones, Geo Inquiry, and for many other things inside this ArcGIS Online platform, you don't even have to be signed in. And another good thing is that your students don't have to be signed in. Nice. So we on the education team are very tight with our development team. We keep saying to them, look, people need to be able to do things inside this platform without signing in. There needs to be some core capabilities where educators and others can, and students can change the map. They can zoom and pan. They can change the style, filter, etc., without actually signing in. So you may say, well, Joseph, why would I want to sign in ever if I can do a lot of stuff without signing in? Well, as you probably suspect, signing in allows you to do things in addition to what you've already done. It gives you more power, more capability. One of the things that you can do is save your map. So let's say Monday you want to teach with this map, right? And you want your students to actually have it appear exactly how you left it on Wednesday morning. In other words, focused in on your school building with the base map as a satellite image and with all your points on there for your trees or whatever you're mapping. If you saved it, then it would appear exactly how you left it. Whereas if you open this map Monday and you go back to this link on the agenda for today, it's going to be actually how you started with it. It's going to be actually panned up to Boulder, Colorado, and it's going to have a topo base. I mean, it's going to take you all of 60 seconds to zoom down to Las Cruces, and south of there. But the point is, you can save if you log in, and you can also create your own content, which we'll do later this afternoon when you make a story map. Yep. Actually, we're going to do it in a little while. So there's additional capabilities when you sign in. You're also going to be able to do some analysis. And I know some of you, especially you middle and high school teachers, you're going to want to say, hey, how many earthquakes are within 100 kilometers of the plate boundary? How many earthquakes have occurred within 200 miles of El Paso? How many cities are within 10 miles of the coast and have over 10 million people? Like maybe that's part of my ocean rise climate change activity. See what I mean? So you're going to be able to do that kind of analysis, but you have to be signed in to actually do that kind of analysis, okay? So signing in gives you additional capabilities. But for you folks that are just starting out with this, and especially you primary school teachers, you, by and large, you can do lots of stuff in here without even signing in. All good. Sehr gut. Muy bien. Okay. Cool?